Sometimes unknown elements are given to us as X or M. Typically we see M if it's a metal, although I have seen it used in other ways, and X can be either a metal or a nonmetal. As we learn more about bonding in a couple of weeks, you are going to understand this way better than you do right now. But one of the things that they will do sometimes is give you what the bonding would be like if it were to bond with a specific element. So in this first example I've written here, you have this unknown element X bonding with chlorine. And you needed 2 chlorine atoms in order to complete the proper bonding structure. So what we need to understand first is that this first element is going to end up with what we call a positive oxidation number or oxidation state. The last element is always negative. So when you go up and you look at oxidation states, they're actually listed in the key here. You'll see that chlorine has a whole bunch of different oxidation states, but only one of them is negative, and it happens to be -1. In this case, that probably means that chlorine is going to gain 1 electron and end up being a -1 ion, or in the process of bonding, share an electron with the other element in order to end up with a slightly negative charge of -1. Now you'll also notice this subscript here, and that's telling you that you needed 2 chlorines in order to pick up the electrons that element X, our unknown element, wanted to either give up or share. So that means that if you were to multiply the oxidation number times the subscript, you will actually get a -2 overall charge on the 2 chlorine atoms, which means that since in bonding you have to end up with an overall neutral compound, unless they tell you otherwise, the X must be +2. Let's do one more example with X and Cl. In this case, again, Cl is -1, and there's 3 of them, so there's a total of -3. The overall charge on our compound needs to be 0, so the charge on X must be +3. Now attempting this for M and O, again, O is the last element in the compound, so it has to be negative. Oxygen, however, only has 1 negative oxidation state. And since there is no subscript, we can assume there's only 1 oxygen atom. If you wanted to, you could do the math then by multiplying, and overall the charge we have on oxygen is -2. The entire compound needs to total 0, so M must be +2, like so. Now the question is, what group or family would any of these elements belong to? In our first example, we decided that X was +2. So what group or family has +2 as an oxidation number? You're going to see it scattered in the transition metals, but you definitely see it in group 2. So it is likely that X is a group 2 metal. It could also possibly be in group 12. Same thing with M here, where we decided it was +2. It is likely, I'm going to change colors, it is likely a group 2. So M is likely group 2 or possibly 12. And then over here, where we decided X was +3, that's a little tougher. It's definitely group 3, but if you look closely, it could also be group 13. So we're going to say this one, whoa. This one could be group 3 or 13.